Okay, yet again, we have come with a very interesting topic in chemistry science. Okay, so there's a question on the board. Write a chemical formula. Write a chemical formula of of this given molecule or compound, magnesium oxide. Okay, so now before we write this chemical formula, it is important to note some keywords. Keywords like groups, periods, valence, and the valence electrons, metals and the non-metals. Okay, so now I'll start with the periodic table. Periodic table. So periodic table, majorly, it can be divided into two components or two parts. Periods and the groups. Okay, so now my main interest is not on periods but on groups. So when we talk about groups that are found on the periodic table at a basic level or elementary level like grade 12, you know that we've got about 8 groups on a periodic table. We've got group 1 up to group 8. Group 1 up to group 8. So now these groups consist of different elements, which are non-metals and the metals. So when you talk about metals are found from group 1 to group 3. This is where you will find your metals. And the behavior of metals is that in order for them to be stable, they always lose electrons. They always lose electrons. Then from group 5 to 7, you find non-metals, and you discover that the behavior of or the nature of non-metals is to gain electrons in order for them to be stable. Then at the far end on your periodic table, which is group 8, you'll find what we call noble gases. Yeah, we'll find noble gases. Noble gases, they neither lose nor gain electrons. They are stable the way they are. They are what? They are stable. I hope you understand that point. From there, we'll talk about valence number, and the valence valence electrons. Okay. So now, if someone asks you what's the difference between valence number and valence electrons, so in a nutshell, valence number simply means the number of electrons that an element will either lose or gain. I repeat, valence simply means the number of electrons an element will either lose or gain. Okay. Then if we talk about or we talk of valence electrons, we mean the electrons that are found in the outermost shell of the given atom. The electrons found in the outermost shell of the given atom. For example, let me give you an example of carbon. Carbon has got a mass number of 12 and a proton number of 6. So when you are drawing your electronic configuration, we are drawing an electronic configuration of carbon. You discover that, for example, this is your atom. This is your nucleus. You write your first shell here. You know that the first shell or the energy level at the advanced level, we call it energy level or shell. So you know that a first shell will always have 2 electrons. Then you look at this element, carbon. You know that carbon consists of 6 electrons because its atomic number is what? 6. So you know that you have used 2 here, meaning you are remaining with how many? 4. So your next shell here will consist of the remaining electrons, which are 4. So 1, 2, 3, 4. So this is what I meant by saying valence electrons. These electrons that are found in the outermost shell, this is what we call valence electrons. Electrons that are found in the outermost shell. Yes. So this is very important to take note before we answer the question on the board. So our major focus will be on valence number. So now, valence number, the way it is, for example, for the metals, valence number for the metals, like I mentioned, metals in the periodic table runs from group 1 to group 3. So every element, each element or every element that are found in group 1, they possess or they have a valence number of what? 1. Similar, again, every element that is found in group 2 has a valence number of 2. Equally, every element that is found in group 3 has got a valence number of 3. Now, when it comes to non-metals, the case is different. Non-metals. So when you're dealing with non-metals, what you do here when you want to find your valence number, this is what we will find. So, like for example, metals found in group 6. So, for example, carbon or oxygen. Oxygen is in group what? 6. Yes. It has a mass number of 16 and the proton number of 8 or atomic number of 8. So this one is found in group 6. So for non-metals, what you do, you subtract 8 from the group number. So for example, the group number for oxygen is 6. You subtract it from 8. So meaning 8 minus 6, you have, your answer will be 2. So meaning when this one becomes your what? Your valence number. So now, why am I talking about all this? I'm talking about all this so that this will help you when you are writing your chemical formulas. Because without you knowing your valence number, it's impossible for you to write formulas of the given compounds or molecules. So this helps you. You knowing the group number, the valence helps you to know or to write the what? The chemical formula. Then the other point to take note is that all metals, all elements, or all metals, they possess a positive charge. Or elements that are found in group 1, group 2, up to group 3, they possess a positive charge. And those elements that are found in group 4, group 5, group 6, group 7, those they possess a negative charge because most of them they are what? Non-metals. I hope I've communicated. Okay, now there's a challenge on the board here. They are asking us to write a chemical formula of the given compound here, magnesium oxide. Okay, so now you go on your periodic table, you check in which group is magnesium. You discover that magnesium is found in group 2. Magnesium is found in group what? In group 2. So meaning magnesium is a what? A metal. So meaning automatically the valence, like I mentioned, the valence number will be 2 here. Positive 2. positive 2. Remember, metals possesses a positive charge, so positive 2. Then this is oxygen. So oxygen, you ask yourself, which group is it found? It's found in group 6. Then I said, valence number for non-metals. You simply subtract the group number from 8. So like oxygen is found in group 6. So you just subtract 8 from 6. Your answer will give you 2. So automatically this one, the valence number would be 2. So negative charge. Remember, non-metals possesses a negative charge. Okay, so this is how to go about. So what you do, you just simply cross like this. So by crossing I mean the valence number for magnesium should go to oxygen, and the valence number for oxygen should go to magnesium. So in this case, it will be 2 and 2 here. Okay. So if you check here, these are equal numbers. So what you do, you can simply divide them or cancel them because these are equal numbers. 2 can go there and 2 there can go there. So meaning your final would be magnesium oxide. So that's your final answer, is magnesium oxide. So you just simply, you knowing the group number or the valence number of a given element. For example, this magnesium, you know that it's found in group 2. So automatically the valence number there is what? 2. Then it has a positive charge, 2. Then oxygen is found in group 6. And I said all non-metals, if you want to find their valence number, you just simply subtract 8 from the group number. So for instance, this oxygen here is a non-metal, it's found in group 6. So you subtract 8 minus 6. So your valence number is what? 2. So there now you just switch, you swap their valence number. The valence number for magnesium becomes the valence number for oxygen, and the oxygen becomes the valence number for magnesium. So now it so happens that for this compound they have equal valence number of 2, so they just cancelled out. So this is our final answer. I hope you are following. Let's go to the next question here. I hope you are following. So number 2, we're going to write magnesium chloride. Magnesium chloride. Magnesium chloride. You know that chloride, we mean chlorine here. So chloride. So let's go. So we know that magnesium is found in group 2. So already it will possess a valence number of 2. Chlorine is a non-metal. Chlorine is a non-metal, is found in group what? 7. So meaning 7 minus 8, it will give you what? 1. There, a negative charge. This is a positive charge. You swap them, like we said. This one goes this side, then this one goes this side. So magnesium chloride. So this one will have the valence number for magnesium, and this one will have the valence number for chlorine. Then you would say therefore magnesium, since this one has got a subscript of 1, you just say magnesium, then this one you bring it here, magnesium oxide 2. Then meaning you have answered. Okay, from there they can ask you also to write the chemical formula for sodium oxide. Sodium oxide. Okay, sodium oxide. So sodium is a metal, oxide, this is oxygen, is a non-metal. So therefore, you know the symbol for on your periodic table is Na, then oxygen is O. So sodium is found in group what? It's found in group 1. So possesses the valence number of what? Positive 1. Oxygen is found in group 6. As usual, you subtract 8 minus 6. So your valence number will be 2. You just see negative 2 there. Then you swap them like that. You cross them. Na. So this sodium will have the valence number for oxygen. Then oxygen will have a valence number for what? For sodium. Then you write them together here. You write them together here. Na2, so meaning sodium 2 oxide. Then you are done. You have written your chemical formula. Okay. Then from there you can do the last one. They can ask you number 4. They can ask you to answer and to write a chemical formula for aluminium. Okay, aluminium. Let me write it nicely. Aluminium oxide. Okay, so this one is involving oxygen. So mate one and land mate one. Okay, so aluminium, this is the symbol. It is found, aluminium is found in group what? 3. So means possesses a positive 3. This one positive, negative 2. As usual, negative 2. You swap them again. Aluminium. So aluminium will have the valence number for oxygen 2 there. Then oxygen will have a valence number for aluminium. Then you write them, you bring them together here into oxygen 3. As simple as this. So this is now you can go about when writing chemical formulas in chemistry. Okay, so on the next video I'm going to teach you on radicals. Yes, now to write chemical formulas on radicals. So stay tuned and please subscribe to my YouTube channel at Jarizi Academy. And if you want to see more videos, so I'll be dropping a new video on radicals. So stay tuned, subscribe, follow, like, and comment. If possible, you can share also. Okay, I guess and hope that someone has been helped. For online lessons, here is the number. For online lesson, here is the number +20964921029. Bye bye and God bless you. Thank you.